So I am the co-chief of the Wall Street Journal's data journalism team, three-member team. That means that I and Rob Barry, the other chief, we take turns bossing around Andrea Fuller. I came to doing data in a very weird way, and I know Armando just called it the modern way, but my roots in doing this stuff with journalism go back to the early 90s when I was a reporter at the Trenton Times in New Jersey. And these guys asked me, this is the truth, these guys asked me to join a baseball fantasy league, and I said I would, and then I got nervous about it. And this editor, Don Henry, said to me, I'll tell you what we'll do. We'll go on to CompuServe. Now, if you're old enough to know what CompuServe is, one of the dial-up services, there was no internet at this time. He said, we'll go on to CompuServe, we'll download all the statistics from last year, we'll throw them in a spreadsheet, we'll calculate all the points, and then we'll go to the draft. So we did that, and we sorted it. Of course, now, today you can go to ESPN or wherever and get all that stuff ready to hand, but at this time it wasn't there. We did it. We sorted by position and how many points the player would have got the prior year. And we did our draft. And all the guys in the basement of this guy's house were calling us nerds and geeks and all this stuff. And we led from the first week through the end of the season. And I got a little bit adept at working with data. This was just in Excel, keeping the stats every week, downloading from CompuServe and doing that stuff. And it also occurred to me that what I did there was very much like what we do in journalism every day, which is come into something we don't know a heck of a lot about, and we have to get up to speed, and we have to figure it out. And I said, this is pretty cool, this is neat. And so I figured out how to do it. Since then, I've basically learned stuff along the way that I needed to, when I needed to get the data for a story. If I were smarter back then, I would have said, hey, maybe I could make some real money with this, but unfortunately, I love journalism, and so I'm stuck in this. So we on the team use probably a lot of the same tools that you guys use. Our main database storage is in SQL Server. We use Excel, of course, a lot. Our statistics has become our go-to tool because it's just so versatile. There's so much you can do with it that's so much better than a spreadsheet and for reproducibility and all that stuff. So we use a lot of R. We do a lot of scripting with the structured data, and we do scripting to scrape websites and to pull in data that we can turn into structured data. So we use like PHP, Python, C#, and VBA. So all the normal stuff. I'm going to go through some specific stories that we worked on. Some are financial related, some are far afield from that, and I think you'll see that we're really all over the map. And we typically, the way it works is we come up with a question and we say, hey, I wonder if there's any data somewhere that could answer that question. And you'll see some of the things that we did. Some mentions of databases that we've used that aren't in the slideshow, just for sort of the breadth. Coal mine data on hours worked, coal produced, safety violations, and other stuff like that. Fatal motor accident data from NHTSA that includes like make and model of every car involved in the collisions, details about the passengers and all that kind of stuff. Pitch-by-pitch baseball data going back decades from RetroSheet, which we employed to address the question of whether designated hitters give the American League an advantage in interleague play. We think they do. Campaign finance and lobbying data, of course. Data from various SEC forums, including quarterly reports and reports of quarterly holdings of institutional managers on Form 13F. My colleague Rob Barry, the co-chief on the team, and Coulter Jones, who was with us on a short-term thing, they last year sent FOIAs to the 110 largest police departments in the country to collect from them their police shooting data. And they put together, when they got that all in, they put together a story that said the FBI statistics that everybody uses all the time to talk about police shootings undercount the homicides by 50%. We use trading data from Standard & Poor's S&P Capital IQ's Express feed, census data, survey of consumer finances, daily short sales compiled by each exchange, and so on and so on. So we're really all over the map, which is what keeps it really interesting for us. One problem with what we do, by the way, is it's very ad hoc. A lot of you guys put together systems where you're trying to, have this thing run every day, and you can pull the stuff, you can feed data into it and make it work, and you can kind of optimize it. Well, we're ad hoc. We get data in, and we try to figure out how to work with it. And so it's more like a MASH unit or something than like a really nice hospital where they work on it. But I'm just going to go through a few of the stories here, and I'll try to be quick because I know it's been a long day for everybody. This one was, you guys might remember last week that Bank of New York Mellon agreed to pay $714 million to settle the currency suits. This is one of those ones I said, making the trouble. We were looking at this claim that Bank of BNY Mellon had basically told their clients that their foreign exchange trades would be done for free, and yet they were sort of charging them actually for them, making money off of them. So we said, well, how can we get to it? And I said, well, let's go FOIA some pension file freedom of information requests with pension funds. And we got them from this one Los Angeles County Employees Retirement Association. We got every single trade that BNY Mellon had done for them. Then we just got the foreign exchange rates for each day, the high and the low, and we plotted out the trades. And you can see that when they were buying foreign currency on behalf of the fund, most of the trades were near the very top of the day's price, and when they were selling them, most of them were at the low. So that was a fun one. Speaking of far afield, this is a story, this was really fun too. A reporter for our Greater New York section, Barbara Martinez, who covered education, said she wanted to look at these Regents test grading and stuff like that, the Regents test that New Yorkers take. And so we FOIA'd for the test scores for every student in New York City. And we got every single test score for every test, but anonymized. And this is a really funny one, because I got this data and I put it in, and within like an hour, I was just laughing at these distributions, because you can see, no problem. You can see what happens here, where the big break right here occurs right before 65, the highest dot on there is 65. So what was happening was teachers who were grading their own students' tests said, oh, Johnny got 63. Can't I find him a couple extra points on there? And so they did. And so as a result, 62, 63, and 64 are vastly underrepresented in this curve, and 64 and 65 are vastly overrepresented. This was not, you don't have to be a super statistician to figure that one out. But these guys who we called experts, they got very excited about it and literally wrote a paper about this in a week. This is, I mentioned SEC forms before. One thing that we're very excited about, we by the way, we don't have like a huge data budget at the Journal. That's another ad hoc thing. When I say to the other, I need $1,000 to buy this data, and like, it's a newspaper. So, SEC forms have been the bane of everybody's existence forever, because they're forms that only a lawyer could like, the kind that you print out and look at on your desk. They're not forms that a data person likes at all. But of course, they've now finally come along to start doing a lot more of this stuff, which is just basically XML, but they call it XBRL, I guess is what they call it. And so it's about time for the SEC to do this. Really funny, I did an SEC story a couple years ago, or many years ago, where they said they were going to do a rulemaking on high-frequency trading. So they're going to open an investigation. And I said, well, so you're going to do an analysis? So you're going to get some data and do some analysis? And they said, well, we're going to get comments from everybody. And I said, but are you going to get like some trading data and see what and they weren't, because they're lawyers, and they just wanted the comments and stuff like that. And they're like the only ones who could really get every trade and have a look and see what happens. So it's very frustrating. So Rob Berry, my colleague, he went and downloaded every single form for all the ownership insider trading forms from the SEC and parsed them and created a big database. And this is one of this. He did a number of stories off of it. He also did a Monte Carlo simulation about the timing of everybody's insider trades, which they would never let us publish the results of a Monte Carlo simulation in the paper. It's more like, go look at this person. But this was just that you can see right before a bankruptcy, in the months before a bankruptcy, how the insiders' purchases go way down and their sales go way up. Another far afield story. Rob went to the Russian election site after that election a few years ago, where everyone said Putin rigged it, and he scraped like some absurd number of Excel. They were all in Excel files, unfortunately. So you had to write a script to go get the Excel files, and pulled them in for all the votes and did some analysis. And the really interesting one is that right one, where Putin won these these round number of the precincts where he won 65%. So this is how many precincts he won: 65% of the vote, 70% of the vote. And so you can just imagine the order coming down from the Kremlin. Okay, you've got to win by at least 65. So they all said, well, they got to 65 and they were good. So, they should have said maybe some of you should be 60, 60, but anyway. This is off of call reports from the FDIC call reports, and our money and investing section had asked me to look at service fees as a percentage, basically service fees by banks. So I did them as a percentage of deposits and different ways looked at it. And they were interested in the big banks, the Bank of America, et cetera, but there wasn't anything interesting to see there. But as I was going through the list and doing the rankings, I noticed there are all these military banks at the top of the thing. You could just tell, Fort Sill National Bank and Armed Forces Bank of California and Fort Hood. And so we did this story about how basically you have these banks that are on military bases. They're not part of the military, but they have franchises that operate on the bases. And their business model is basically overdraft fees and everything for the soldiers and everything like that. So. This is another one that probably making trouble, definitely making trouble. We got like 4 years of every flight in the country by the FAA. And we sort of, I guess our methodology was we took a lot of we figured out every resort location that we could come up with. And we, airport code, and we just counted what percentage of each plane's flights went to those places. And Stanley Tucci Joseph Tucci was Stanley, the actor. Joseph Tucci was a real standout from EMC Corp. I hope there's nobody here from EMC. And he, went. A lot of that company's plane time was spent flying to his. Well, we don't know that he was on it or anything like that. We got to make that clear. But the planes were going to the places where he owned vacation homes. And we put this jet tracker up online that a lot of people had fun going through, so you could look up the flights for any tail number or any company name and stuff like that. This is like more complicated than making it sound, because a lot of these planes are owned by LLCs and other stuff, so you don't really know who's flying it. So we had to do a lot of work to figure out who actually was operating each plane and stuff like that. How am I on time? Okay. This was, I just was really interested in this. Rob and I are both sort of aviation geeks. We're into flying and we're just interested in it, Rob Berry. And so this plane crashed, and right away they said, the Asiana crashed in San Francisco. They said that the glide slope indicator was out at the airport. And if you don't know, when you're flying into an airport from a ways out, the pilot, the plane's instruments can pick up this beam from the airport, and that beam will tell you the descent path to follow to land right at the right spot on the runway. There's also another system that keeps you centered on the thing. So this indicator at San Francisco was out for the two runways, 28 and 29, I guess. It was out when this crash happened and had been out for a while because they were doing some runway work. So I said, I wonder, this guy landed short, right? He didn't make it all the way to the runway. I said, I wonder if that has anything to do with it. And Rob and I both got interested, and so we started figuring out how we could address that question. So we contacted one of those flight tracking services to say, what data do you have on planes going into San Francisco? And they said, we'll give you 3 months of fixed data for these planes, which is every fix tells you here's the latitude, here's the longitude, and here's the altitude of the plane at this given moment. And they gave it to us, and there were like 50,000 flights in there and about 630,000 fixes. So each flight had a number of fixes. And that average fixes per flight was 13, and that turned out to be a big problem. Just looking at the data, like this plane right here, it's sort of cool. Oh, I should mention, so we were thinking of doing, how do we come up with quality of landing? Like how easy or hard it was to land each plane. And we were actually trying to like come up with how far they were out, how high, and all this stuff. And it was the precision of this is not good enough, the precision of this data. So we decided, well, let's just see if go-arounds, right? When a plane comes down to land and if a pilot doesn't feel like he's in good shape for landing, he'll just pull back up and go around and give it another shot. So we said, let's look at go-arounds and see if those tell us anything. And so here's a flight from the data we got from that flight website, and you can see sort of we plotted out the path of the flight and went around, and you can tell in the data where it goes from 4,000 feet to 3,000 to 2,000 and whatever, and then it goes back up in the air. So we just didn't have enough data from them. Some flights had like very few numbers of points that we couldn't draw any conclusions from this. And then I found this website from some NASA guy put this thing up, and it was TRACON data from Northern California's TRACON, and it had 133 fixes per flight. He had gotten it from them. So you can see that gives like a beautiful, beautiful path of the flights. And so I don't want to go into too much detail on this. We ended up FOIAing, filing a Freedom of Information request to get that data from the FAA, and we got 341,000 commercial flights, I think it was, 130 million fixes for those flights, an average of about 378 fixes, and the fixes every 5 seconds typically, by the way, and it went from 3 months before those runways were the glide slope was closed to 3 months after, which is key, obviously, right? Everybody, we got a period to look at. So, you know, you could look at any one of these and say, did it go up and down or whatever? Of course, we created an algorithm to figure this out, to go through each flight's things, each flight's fixes, and we wrote it in PHP actually. We could have done it in Python or anything, but it was a PHP algorithm that would like query each flight's fixes from there and then go through them sequentially. And our rules were pretty simple, that it had to be above 5,000 feet at some point, had to descend below 2,000 feet at some point, and then had to climb back above 3,000 feet at some point. So that's a simplified version of what the whole thing says. And if all those things come true, then we say it's a go-around. So we've came up with 991 go-arounds, and we plotted them out in R, plotted out every one of those paths in R, and because the only way to confirm that our algorithm was right to actually look at them and see. So one morning I spent going through 999 pages in a PDF, you can see this is erroneous data. Two different planes had gotten the same flight ID somehow in the TRACON data, so it fooled our algorithm, but the rest of them were really go-arounds. We also used GIS stuff, of course. We compared weather for all of these things to control for weather in case from before and after to see if it was any worse or better during the thing. Whatever. And this is the ultimate finding and it was statistically significant, by the way. We did test that. You can see that the foreign carriers had a lot more trouble when the glide slope went out than the American carriers did, according to the go-around metric. It's not perfectly bulletproof because there are a lot of reasons for go-arounds. The tower could tell you to go around, but we just said it suggested that they had more trouble. And Asiana had the highest rate of them all, by the way, and they had one the day before this where they were about to land, and they executed go around 400 feet above the ground. We got time for, is that it? Okay, that's done? Okay.
Well, we definitely have time for some questions.
Okay.
So just raise your hand. Actually, I have one for you, though, because
Okay.
I really found your examples really interesting. So could you go back to how do you use like the scientific process to decide how you go about investigating a story when you think about using data, or have you guys come up with a new process?
How do you mean, like the scientific?
Well, do you have come up with a hypothesis of, I think I'm looking for this, and you start digging into the data, and then you test it out? Or?
Well, like this one is an example where we wondered if the glide slope made a difference. But what did we measure before, and what did we measure after, right? And so, like I said, we started with like these, were they divergent from the center line, or were they coming in high, or were they coming in low? And the data is not accurate enough to do that. And I don't, somehow I struck on the idea of doing go-arounds, and it worked. So, yeah, I mean, like I said, it's very ad hoc. Everything we do is like a different problem and a different data set, and trying to understand the data set, understand its limitations, because a lot of this government data, for example, is very messy. And so you got to understand how much you can rely on it in the first place. Of course, all the stuff that you all deal with on a much more expensive level. Anything else?
Great. Okay, that's Tom McGinty for you guys from the Wall Street Journal. Thank you.